Okay, there we go. Okay, so let's get started. And welcome to the community meeting for the for WasmEdge. And so we're gonna be in Seattle this later this week, actually from today, later today until the end of the week, for the WasmCon. So there are lots of going on there, and we're gonna make some really exciting announcements. And there's gonna be a Wasm landscape, with over 100 projects. So so if you're in Seattle, just let me know, and we should meet up there. So anyway, today we have a packed agenda, and we have 4 talks, and some of them I feel are very exciting. So without further ado, let's get started. So the first one is from Mark, and he's one of our Airvax mentors who worked on a project that's use Wasm as a log processor. So the idea of this really come from a lot of companies and customers that I talk to. So when I tell them we have a new lightweight sandbox service that can run in a container environment, what would you run for? And a lot of them told me that's one of the most heavyweight and CPU consuming services that they have in their Kubernetes cluster is actually log processing. So they typically use the ELK stack, right? So Elasticsearch, Logstash, and what's K? I forgot, but it's 3 JVMs. So Logstash is essentially the key component where it runs a Java application and extract logs from, say, the file system or MySQL database, and then transform it and then forward to Elasticsearch for visualization and for searching and things like that. And it's a very people consider it's a very heavy setup, and it's very costly. So to have a lightweight component to do the same work, essentially using Wasm to replace the container plus JVM is an appealing solution to a lot of people. So that's why we work on this project. And I think we reached a nice milestone. We can demonstrate, taking data from MySQL and transform it, and then send it to Kafka or send it to Elasticsearch. Yeah, so if you guys have similar needs, we'd love to see you guys try it out and maybe contribute back. So yeah, so without further ado, let's get started. So Mark, please.
Okay, can you hear me?
Yes.
Okay. Okay. So hello everyone, I'm Mark. I participated in the LVX mentorship program this summer and created this log processing framework called Wasm log facts. And I'm glad to give you a short introduction to it today. So what is a log processing framework in our context? Well, it's a way to standardize the process of logging in your application. So nowadays we have millions, if not millions gigabytes of log data per second. These logs have tremendous value in it. We use them to troubleshoot issues, gain insight of our business, and so on. So there must be a good way to take good care of these log processing, these log data, and that's what the log processing framework does. It collects, transforms, and stores your log, and maybe you can use it to analyze and visualize your logs. So what's wrong with the current log processing service, and why we need a we need to create a new one. So as Michael has said before, current log processing services like the ELK stack is too heavy. They make use of Linux containers and JVMs that are not so efficient and fast. So to utilize the lightweight WasmEdge runtime, as well as exploit Rust's superb performance and security, we created this log processing framework based on the WasmEdge runtime. So with that being said, let's dive into the design of this log processing framework. So conceptually, there are three types of components in this log processing framework. The first one is collector. It collects logs from various services. For example, the collector can collect from my circle bin log or just a regular file. And the second one is transformer. It manipulates logs that are collected from collectors or from other transformers. And the last one is dispatcher. It dispatch process the logs to their final destinations. For example, they can store logs in Kafka, Redis, or Elasticsearch. So for example, this graph gives you the idea of how everything are put together. We have two collectors here, one collecting logs from my circle bin log, and one collect from maybe K8s pod log. And there are many transformers. One could parse my circle bin log. One could aggregate logs from different collectors, and one could encrypt log. So finally, there are the dispatchers. They dispatch logs to different endpoints. For example, one dispatch log to Kafka, and the other just writes logs to file or send them to Redis or MongoDB, like something like that. So next, I will show you some key traits that are required to implement these customer collectors, transformers, or dispatchers. So firstly, we have the component API. So a component is a generalization of collector, transformer, and dispatcher. Each component must have a unique ID, which enables other components to route events to it. Then we can run it by giving it a router as an argument. The router API is the way to transfer or send events in between these in between the processing framework. So as you can see, you can ask the router to send events and pull events from the router. And one important thing to mention is that all components must be registered in the event router first before they are used. So here is an example usage of this. So firstly, you will need to create a router to route all the events. Then you create the components. For example, here we create a bin log collector, a table parser, and a Kafka MyCircle table dispatcher. And then we register them in the routers. And finally, we run all the components asynchronously. And then the logs can be automatically collected from the MyCircle bin log and then forwarded to Kafka. So of course, if you don't want to write the code before and just want to use everything that is already cooked together, I created this WLF-AIO, which means Wasm log flags all in one Wasm binary, which allows you to write YAML configurations or just use Maxwell configuration to run the binary. And as you can see on this configuration, we have the bin log collector and the filter and the replicator, and all you need to do is to write this configuration. So I think that's it. Thank you.
All right, thank you, Mark. And this, I think this is very, very useful because people keep asking me, how do I get started with a WASM project that's not a hello world, and this would be it because everyone has a MySQL database, right? And everyone, this is something I think you can immediately use, to replace some of your workload. So go try it out. And thank you, Mark. And really appreciate your hard work on all this. And I especially like the idea of ingesting Maxwell config directly so that we can, because a lot of systems are set up this way, so we can directly use migrate existing systems to there. So thank you. Yeah.
Okay, thank you.
All right. So the next up is another very useful use case for WASM. It's actually one of the original use case for WASM on the server side, which is, we talk about WASM in the cloud native environment, but when WASM first moved out of browser, that was actually used in the decentralized cloud, right? As a smart contract execution engine on blockchains. That's actually the origin story of WASM. And WasmEdge, of course, is used by several leading blockchains. And so the next up, I want to ask Loredana and to come up and talk about the work that they have done for using WASM on the in smart contract and blockchain context. Please, thank you.
Okay, I hope you can hear me and you can see the presentation.
Yes.
So hello all, I am Loredana Cirstea, and I'll be talking today about WasmEdge enabling a universe of compute, which means any language, any source code, any bytecode. In this case, applied to a governable, modular by WebAssembly individual modules, upgradable living system in the form of a blockchain built by and for volunteers. So we'll talk a bit about this multi-execution environment / language collaboration. First, why do this? Second, I will show you an actual live demo on our current testnet. And if I have time, I'll talk a bit about WASM meta contracts, which are WebAssembly modules implementing core features of the blockchain, and about encoding, decoding data passed between smart contracts and execution engines, WASM execution standards, and some examples of WasmX host imports. WasmX is the name of our module, and Mythos is the name of our blockchain. So on why Mythos as a project, I can say that it started 2 years ago from one smart contract, which was the Laurel project smart contract on Ethereum. And this was a very flexible system of peer-to-peer rating of effort, of volunteer effort. And this was done by a continuous voting on a system with reputation. And it was very flexible because it had coefficients everywhere. So this means that we can repurpose the project in multiple ways. One of the ways was even as a governance system for artificial intelligence. And this non-profit project has expanded now in a fully fledged blockchain because we couldn't implement it in other ways. So this is the first project, as of my knowledge, to actually implement a functional multi-execution environment collaborative system. There are other projects that may have maybe 2 execution environments, and it's usually either they are hard-coded in and you cannot add easily other environments, or they have a separate state for them. So I'm talking about a system that already supports JavaScript, Python, Golang smart contracts, assembly script, Solidity with the Ethereum VM, and Rust with Wasm. And now to the why. Decentralized public systems are an actual implementation of democracy at various levels of magnitude, of course. And the holy grail of building a decentralized public system is that you can use this system to govern its own existence. So we are talking about one universe in which all of these execution environments share the same global scope / storage. And the way you can actually implement this is if your most important feature is flexibility. So this leads us again to multi-execution environments. And now the demo. I actually have this demo in a more detailed video on my YouTube channel where I have technical videos in case you want to maybe pay a bit more attention. So now this is our dApp in which we deploy and interact with smart contracts. And I have already uploaded a Python smart contract, and the source code is here. Let's look fast about with what it does. So it has an instantiate function. This is when done one single time at deployment, and it just stores a variable. In the case of the Python contract, it stores Python. The JavaScript contract has the same logic, but it stores the word JavaScript. The Golang contract has the same logic, and it stores TinyGo because it's compiled with TinyGo. The Python and JavaScript contracts are actually interpreted by interpreters compiled to Wasm, but the Golang contract is compiled with TinyGo into a standalone WebAssembly module. So each contract has its own identifier string here. And then we have 2 functions, forward and forward get. Forward is a state changing function, it's a transaction, and forward get is a query. And what these functions do, forward takes an initial value, it's a string that you give, and then it concatenates that string with the word Python that it has stored in the contract storage. And then it does a log, a blockchain log or event. And then it receives also an array of addresses. And what it does, it forwards the call to the next address in line, and so on. And it uses the call method from the WasmEdge SDK that is provided here. The forward get function is similar, receives an array of addresses and just forwards the query to the next contract. And then it takes the result and it concatenates it with the string that the contract has stored during initialization. So it just adds Python and then the rest. And we'll see this soon in action. So I've already deployed these contracts on chain. I also have the JavaScript contract here, and the TinyGo contract was uploaded as a WebAssembly module. So I got these addresses from the other contract. You have them here, the JavaScript contract address and the TinyGo contract address. And I have here an initial value, which says atomic transaction. We will be communicating with our current testnet, and we have an explorer for this. through the Kepler wallet. So we will just do a transaction. Sometimes Kepler delays this a bit, so we'll see soon a prompt to approve the transaction. I don't know if you see it. I'm approving it, and we should see already that the transaction was mined. And in this block, we can look at the transaction here. Let's see. Maybe the Explorer has a bit of a bug, so let's search for the transaction hash directly. Okay, so you can see, and I'll put a link to this transaction here. This is an execution transaction, and you'll see a bunch of logs here that we will look in detail in the DApp because it shows them a little bit better. So what happens is that each contract emits an event. So we should see in the last 3 events, which are of type WASM log. And you get the contract address of the contract that was executed. You also get, this is the encoded data that I just logged, and we can use an ASCII data decoder and we see atomic transaction. Python, this was added by the Python contract. And another interesting information that the logs have are the dependency. So this is the main system dependency, and it tells us exactly what version of the execution environment was used to actually execute this subcall. And in this case, it's the Python interpreter with the version and UTF-8. It's because I've actually used source code to deploy the contract. You can also have bytecode, direct bytecode that can be understood by that interpreter. And now the second log, and let's see the data first of the second log. This was executed by the JavaScript contract, so it added the JavaScript word here. And let's see the dependency. And of course, this is the address of the JavaScript contract. The dependency is on the JavaScript interpreter of this version. And the last one, we'll copy the data and look, the dependency now is not on an interpreter, but it's actually on the WASI snapshot preview 1 standard because it's a module compiled with TinyGo. Just a moment. Okay. So the last piece of data that we convert is Python, JavaScript, TinyGo. And we can also call the forward get function that receives an array of addresses and is a query. And mind you that the JavaScript and Python interpreters are not AOT compiled right now. So they are not the most efficient as they can be. So we get the decoded data here. It went through the Python contract, JavaScript, and TinyGo. We can remove one of these addresses and do the query again, and we should get Python and TinyGo. So this is a demonstration that you can have 3 contracts written in 3 different languages. Now we got the response, Python and TinyGo. 3 different languages executed in 3 different execution environments that can collaborate with one another. In this case, they collaborated through JSON, the JSON format. So a couple of words about why we chose WasmEdge. It's that we've seen that it moves very fast. We've seen a focus on machine learning and AI, which is something that we're also interested in. Shared memory support and AOT compilation, which gives us efficiency. So we have the flexibility, and with by compiling the meta contracts in the highly used modules, we can also have efficiency. And in practice, we've seen 10 to 30 times lower execution time. Especially what interested us was an electronic ID signature verification. We went from 35 seconds to less than 3 seconds. And it can do even better because we actually need to use 2 WASM modules for this transaction, and only one of them was AOT compiled. We had some issues when we compiled both. So if that works, the execution time will go even lower. And we're interested in AOT for at least Linux and Mac OS. Both platforms, we've had some issues with the ARM. Specifically, I tested on an M1 Mac OS, and I had some issues. So we'll see there in the future, but the signs are very good. And we hope to see soon that languages like Mojo, the new Python AI language, will support WASM, and we can use it with WasmEdge too. Very short explanation about WASM meta contracts. These can be interpreters, compilers, transpilers, governance and voting contracts, different types of encoding, different types of consensus even, and all sorts of contracts for currencies, points, ratings, medals, and so on. And the idea is that anyone can deploy such a contract. They can battle test it on chain, and then they can decide whether to promote it or not to core level. So you can propose, test, vote, apply on chain, and this on a live running system. You can think of this as hot upgrades. So you should be able to add at any point in time new languages, new encodings, and so on. And for encodings, you can go the route of using a common encoding like JSON for these 3 contracts, or different encodings, because we also have EVM, for example, and you can choose to either embed the encoding source code in each contract, like COSM WASM does with JSON. You can support encoding in the base layer, or the ideal route for us is as a standalone WASM module. So you can have WASM modules that go from whatever encoding you want to use to the execution environment native memory representation. So this means you have a very fast contract calls between contracts that use the same internal representation, and you also are very storage efficient. And WasmX supports multiple execution standards. This means the multiple entry points that you can have in WASM modules, different memory allocations, reading and writing, and all of these are abstracted out as system dependencies. So when you upload a smart contract, a WebAssembly module, you have these system dependencies analyzed from the WASM smart contract, or in the case of interpreted smart contracts, you can declare them. And also, system dependencies can be, besides these labels and roles, they can be the identifiers for the WASM modules, the so-called addresses. So this gives a lot of flexibility to the system. WasmX host functions are based on raw byte arrays, and these are just a couple of examples of WasmX in C, Rust, and Golang. And that's it. From my side, we are still building. We are focusing on flexibility. And if anyone wants to help and validate this system and test Mythos, they can join our Discord.
Oh, that's great. Yeah, that's thank you. Yeah, so do you want to put up your Discord barcode, or on the screen, or maybe the link in the chat? Yeah, so I've always okay, so I've always
I just posted the transaction in the chat. I'll post the link in for the Discord in the chat from the Zoom.
Okay. All right. Cool. Yeah. So, that really reminds me, the work we've done in WASI really is provide, operating system access to WASM, but, blockchain is not running on the regular operating system. You have your own way of storage and address and all that. So you need your own extension. So, so that's, I know Ethereum has a way to do it. They used to have the UWASM, right? And so I guess every blockchain have a way to do it now. So, it'd be nice to see that standardized and, so that it can go across languages like you have just demonstrated. That's
yes,
super.
we actually have Ethereum integrated. So we have eWasm implemented and working with the latest version of the EVM.
That's excellent. Yeah, that's we really look I got to look more into this space because I haven't done it for a while. Yeah, it sounds like the work that you have done is really impressive. And for the AOT bugs that you have encountered, that's please do get in touch. And we like to, because those are not just your problem, it's everybody's problem, right? So we'd really like to make our AOT compilers more robust. Thank you so much. Yeah. All right. All right. Yeah. So in the interest of time, so let's move on to the third topic. The third topic, DM4 gonna come to talk to us about something that's I think I just released this morning, is to use WASM and WasmEdge to run large language model. I'm talking about full-blown Llama 2, not just the baby llama or mini llama, that we have demonstrated before, and also runs it on GPU instead of just the CPU. So DM4, are you ready?
Okay. And can you hear me?
Yes, I can.
Okay. Today I'd like to discuss running ggml-LLaMA model with WasmEdge wasi-nn plugin. Before that, I'd like to do some demonstration. After download this Llama 2 7 billion model, this model is quantized by ggml and it's 3.6 gigabytes. And I have a demo script here. First, we compile this cargo project, the Rust project, and use the WasmEdge C to get the LT Wasm. And then we use the WasmEdge command line tool with the preload function. I'll talk about the preload feature later, and give the prompt to the model. And when after the WasmEdge loading the model, it will generate the output text. Yeah. Yes, that's the result. Okay. I can talk about this. Back to my slide here. In WasmEdge, the new version of WasmEdge we released this morning, there are several new features and new updates. And there are two particular features it's relevant to today's topic. The first one is the load by NaN implementation, and the second one is ggml backend. And both these are implemented in wasi-nn plugin. With the first NaN model feature, we can preload large model into the wasi-nn plugin. And for instance, you can use this like this WasmEdge command tool and use the -nn preload flag and give the model name. This model name is for the wasi-nn to identify the model, and the backend is what type of the model file is, and the type is the model. You want to use CPU or GPU or TPU, and the model file on the disk, and run the wasm file. Then WasmEdge will preload the file to prevent some performance issue and load the file to wasi-nn plugin. And the ggml backend, we can employ the ggml quantized llama model for inference. Yeah. As we talked before, use the preload flag and choose the ggml backend, and currently only support the CPU and the model file name to run the wasm file. And to accomplish this, we need to pass the input and get the output from the wasi-nn plugin. We simply pass the prompt text as the input data to wasi-nn plugin. This is a Rust code I've just used. Yes, convert the prompt to the ubar vector and pass it. And the output, we just get the output data from the buffer and convert it to string. Yeah, I think that's it. We'll put the example code to the wasi-nn example later. Yes, I think that's it. Thank you, everybody.
All right. So yeah, that's people have asked me, why do you guys want to do that? The reason to do that really is to get rid of Python dependency at the inference, because as we know, Python is really important, when you do training, because you need the interactivity. However, it's wrong to use for inference. And in fact, when you talk to most big companies like say Google and companies like that, they all use C++ to do inference because it's just a lot faster and a lot lighter. And yet, most of the long tail companies like independent developers and also smaller companies are still using Python because it's easier, right? So then fast forward to the large language model era where the efficiency become much more important. Python comes often at 1 gigabyte Docker image, right? So, and it takes a long time for it to start, to load, and then to manage dependency. It's really complex. If you look at the new popular inference tools like llama.cpp, which is part of the work that we base our work on, it has a very strong point. It's a Python zero Python dependency. It's written in C++. However, with that, you also lose the ability to, or it makes it difficult to interrupt with other languages and put it in a sandbox and things like that. So our approach really is to make this whole stack runs inside Wasm instead, and use the wasi-nn API to do this, right? So like DM4 has said, we have just released the new version of WasmEdge, I think an hour ago, and we're going to publish a full example of GGM inference, Llama 2 inference, in one of our example repositories. And from there, you can download your own model and try it on your own CPU. It runs fast enough to even just on the CPU. If you have a GPU, it would be it also be a lot faster, but you may need to recompile the plugin for GPU. GPU support is there, but it's just harder to do. So so we'll settle with the CPU first. So that's so with all that, I think there's it's very exciting for us because now we can make this type of large language model, incorporate that into serverless functions, incorporate that into microservices, incorporate that into a lot of places that the Wasm can run, and also provide a performance and a developer experience that's much better than, hopefully much better than Python. So we're gonna have more contents and materials and also demos and so just join our Discord group, or follow us on Twitter. That's you would get you would get updated information about all this. So great, yeah. All right. Thank you, DM4, and we'll leave the questions to the very end. So then the last talk, I think is also very interesting, because one of the #1 issue developer has faced with Wasm is the lack of debugging and observability tools. And debugging is coming, by the way, but as part of the story, there's we can also we now can have a WasmEdge plugin that implements the WASI-logging standard. So it allows you to use the standard Rust logging crate to log messages out of it. So you can it's a poor man's debugger, right? And because of the Rust logging framework can connect to different destinations, so you will do a lot. You will be able to do a lot of different things with it. The developer for this project, I think he's busy with he has other engagement today. So I asked him to record a video. We're gonna watch that video now, and that'll be our last talk. So Vivian, can you please play the video?
Sure. Can you see my screen?
Yes, we can.
And I'm the developer of WASI-logging. My name is Wen-yuan Haung, and I'm the developer of WASI-logging. Today, I will show how to install WASI-logging and how to use it. If you have any question, please contact me through the email. So what is WASI-logging? WASI-logging is a simple logging API. It is usable as an stderr destination. It can work as logging output in a headless program. So how to use WASI-logging API? WASI-logging API has 3 inputs. The first input is level, and WASI-logging supports 6 logging levels such as trace, debug, info, burn, error, and critical. As for the context, its data type is a string. So as you can see in the logging use case, we can put FYI here as a context, and FYI here is a string. As for message, its data type is a string. So here we can see you can type the program is running here, and it is also a string. So how to use stderr? So we just need to type stderr in the context, and the message will redirect to the stderr. So how to install WasI-logging plugin? You can directly download the release from GitHub and follow the installation guide on the GitHub page. So here is the release. You can download the release and zip it on your terminal. And you can follow through the installation guide here. So here, I already downloaded the WasI-logging plugin. and we need to open it and put it into the plugin directory. Also, you can install WasmEdge plugin by yourself by compiling the source code here. Moving the library to the plugin directory. So as for running the example location is at WasmEdge examples plugin WASI-logging. So we move to the directory. And then we need to build the source code. The source code is written in Rust. So we need to install cargo. After doing this step, the Rust file will be compiled into .wasm file, and then we can execute the Wasm. Then we can see the output. So for the basic use case, as we can see on the slide, we can put context here. Context here is a string, and the output message is trace level message, just like we can see on terminal. And for different kinds of logging level, they have different colors and write down which level it is. So if we check out the source code, here, context is a string, and the string is FYI. So it is the same as our output. As for using the login with our context, here, you can see there is no context here. As for using the login with direct the message to standard error, which just need to write stderr in the context here. You can see, yes, we write stderr here. So if you redirect the standard error output to a file, just like this, you can see this part is missing, and it is being written to err.text. So here is today's demo for WASI-logging, and thanks for your attention. Bye.
All right, thank you. Yeah, that's we are building up all those WASI-like plugins, so there you can expect a lot more features with each release of WasmEdge, from this point on. So yeah, that's I think things like WASI-logging, it's sounds like a small feature, just logging, but it's something everybody can use, right? That also echoes back to the very first talks that we had today. Is that it's a logging processing framework. So if you guys have have any kind of application, I'd encourage you to try it out. Because that's because it's a very easy way to get started with the right way of doing logging. Because if you are using ELK, it's very heavyweight. If you're not using ELK, I hate to say that, but you are probably missing a lot of stuff, because you can mine a lot of information out from the logs. Anyway, so yeah, that's okay. So I think this week there's two very interesting conference going on. There's WasmCon and in Seattle, and if you guys can make it, I'd love to meet there. And if you don't, it's a CNCF conference, so so there would be a live stream, and also it's together with Rust Global, because Rust Foundation, interestingly enough, that's the only conference Rust Foundation runs this year, and in conjunction with the WASM conference, right? Because in their mind as well, WASM has quickly become the I would say the primary compiler target for Rust. So it becomes more and more important in the Rust ecosystem as well. So if you can go there, let's meet up. If you can't, there's video. So there's live streaming. So and then there's a Civil Navigate conference, I think, in London, where they also have a lot of WASM content. So if you're in Europe, that'd be the place to go. But of course, that's it has already started, and I believe that conference next year is in Austin, Texas. So so that's would be at least convenient for me. So well, if you have other questions, just we're gonna hang around for a couple minutes, and just watch for the llama and LLM demo that come out that will come out later today. That's I'm gonna head off to the airport to go to Seattle, in about an hour, and I hope by the time I get there, we would have a full demo that we can tweet. So yeah. So Shivi raised a hand, and so Shivi,
Hello, am I audible?
Yes, we can hear you.
Hi, Michael. Yeah. I was supposed to come to WasmCon, but I mean, my passport actually got stuck in some other visa that I was applying for. So unfortunately, I won't be able to make it live. But hopefully, I'll catch up with you at KubeCon. The main question that I had was that, of course, right now, if we look at the Run WASI project on GitHub, right, like we have one of the shims, like the Wasm edge shim is present there, apart from like the regular slide and the spin shims. But when we look at the container Wasm shims, we have the shim for lunatic, slide, spin, and the worker, the what is it? The WWS, which is basically the Wasm workers, right? So, is there a specific reason why we don't find WasmEdge in the container Wasm shims?
Container Wasm shims, it should have WasmEdge in it, right? That's how we do Docker integration.
No, so yeah, I'll basically just share with you. So this is the URL that I'm talking about. One second, I'll share it. So
okay.
This is the official.
Yeah, because it's I guess it's managed by DS Labs, right? That's so I have to look into that, because there's different organizations involved. I think there are Container D organization, which is the CNCF, but DS Labs is part of Microsoft, so they have their own thing. So it's I don't know. I mean, so I we'll have to sort it out. Yes, thank you for for reading this issue to us.
Yeah, no, sure.
Thanks. Yeah. Okay. So Brad Jones asked a question. Do we have an ETA for 14.0? It's 0.14.0. So we are not at 14.0 yet. We are not even 1.0 yet. So it's well, it was supposed to be released in this version, but we decided to release 13.4 instead, because there's a big feature in 14.0, which is reference types and GC. Those go together. And that requires a lot more testing, because that's the foundation for component model. So unfortunately, there's we also diverted resources to do the llama integration for this release as well. So so for now, we have to settle with 0.13.4 instead of 0.14.0. So but that should come in the next release. So yeah, that's in a month also. Yeah.
Also, I guess like today, Fermio also like kind of released one such integration, which was they have released like something called as the Fermion Cloud Serverless AI. They're essentially using the CVO GPU to be able to make the inference.
Yeah. So that's they're doing it in a way that's that's how they do that networking and all that, right? They have a separate SDK and a separate API that that you have to use in order to compile to Spin, right? That's you have to use the Spin SDK for that, right? So our approach, both from networking and from inference, are very different from them. So I guess that's why there's reason for both projects to exist, right? So for instance, in our networking, if you do that, then you essentially can't do non-blocking network, because every call you goes out to the host, and then inside Wasm you have no idea where the host is executing. But in our case, that developers, first of all, they don't need to learn new API. They can just use Tokyo, Hyper, request and whatever, right? And then they can have 4 asynchronous APIs in terms of networking, which I think is quite crucial for things like microservices. And in terms of LLM, I think it's the same story. You can have a separate host function that goes out to call the LLM, which we have that on flows.network as well. However, that's not in my opinion, that's not a general way to do AI inference, because at WasmEdge, as of today, we support the entire media library, which has 4 or 5, maybe around at least half a dozen, different AI models. We support PyTorch, TensorFlow. We don't just support Llama too. There's a array of, image processing, video processing, OpenCV, FFmpeg, YOLO, and all those, AI frameworks that's either has been supported on WasmEdge and people are using that, or has been is well on their way to be supported on WasmEdge. And the LLM support is just one thing that's in addition to that, right? So our goal is that all you need is Wasm. All you need is to install Wasm that come default with your Linux distribution. In our case, it's Fedora has that. I think Ubuntu would soon have that as well. That come default with your Linux distribution, and then run the Wasm application, and that'll be it. There's no other thing to install. There's no that would be the container. There's no another native application that wraps around the Wasm runtime, right? Like Node.js or Spin are set up this way. So so I think this is a very different ways to do that. And I'd love to try out Spin Clouds that essentially made this as a cloud service, right? That's you write application, you learn their API, write application using their API, and deploy on their cloud, which is what we do on flows.network. That's but if you want to the full open source route that run everything on your own computer, on your own Mac, and just have the Wasm runtime. So that's long-winded way to say the difference between those two projects. But I like what they are doing, but it's just what we are doing is very different. So
By the way, Michael, just one quick question. So there is this like one application called pieces.app. It's not an open source application, but the idea over here is that they are kind of coming up with So it's essentially this code snippet application. Like you can very easily just manage code snippets, and you can easily like extract code snippets from your entire code bases and store those under one location. But recently they came out with this Copilot, uh, like very similar to GitHub Copilot. This would essentially be in your VS Code, and you can ask any questions to the Copilot related to all of your code snippets, right? And in order to do this, like they have two options: either you can use like their cloud version, or if you don't want to use their cloud, you can also leverage the use of a popular LLM, like let's say Llama, locally. But of course, given the fact that running LLMs locally is very it is very performance constrained. So they have like minimum RAM requirement. For example, like if you're running the most bare bones model, then you should have at least like 6-7 GB of RAM, and the application will take up that much amount of space. So is there any according to you, like the solution, once the demo that you mentioned for Llama gets released for WasmEdge, where so like let's say for a user who is using this particular application locally and they are also using WasmEdge to run the LLM, then they could use the WasmEdge implementation for that LLM and then power this like specific Copilot feature of this application. So is that
Yes.
like one of the use cases that we can probably look at?
Yes, I think you're absolutely right. Although, the model have hard constraints, right? We are not claiming that we can make the model run fast, because the model itself runs on the GPU. If the model is 7 GB, then you need 7 GB of GPU memory to do that, right? But what we are saying is that what we have saved is the Python piece, because, in order to set up PyTorch, for a lot of people, it's 1 GB right there, so that makes a huge, it makes less difference than, say, if you just run it casually on your laptop, compared with, say, set up PyTorch, right? But say if you run it as a microservice inside Kubernetes, that makes a difference. So but you're absolutely right. Things like that, the self-hosted Llama is one of the things that that could be really useful. That's I'm sure it would be useful for the Spring Cloud as well, because they can host it as a serverless function there, right? It could host as a as a WasmEdge serverless function, if you have the infrastructure, which I presume Flows.net will soon have. But but today you can just start your own server and run WasmEdge on it, and have a large language model attached to it. Yeah, that sounds like a very interesting project. We'd love to see, if that because this is a very common use case. So almost all the note-taking applications have this feature now, like Notion has it, and that's to learn from your own notes, to fine-tune the model with your own notes, and answer questions based on your own notes. And that's this seems to me it's a very solid use case. That's I love to try that, and I love to make WasmEdge working with that. Thank you.
Yeah, I mean, because immediately once they kind of released their Copilot, I immediately thought of like how we could improve the local performance. But I mean, it does make sense that if the LLM will require like 7 GB of GPU memory, like we cannot really change that. But yes, there could be certain improvements that could be made potentially.
All right. Yeah. Yeah. Just as you can see, there are lots to explore, right? It wasn't a possibility to run LLM inside Wasm yet, and and now it's possible. So let's go try it and see what other use cases we can come up with. Yeah. Thank you. All right. So I think we are 8 minutes over, and I got to go to the airport now. So thank you so much, guys, and we're gonna see you on the WasmCon live stream, or see you on Twitter. Until next month. And
Have a safe flight, Michael.
Thank you. So see you guys. Thanks.